Hey guys, welcome back. We are looking at calculating probabilities using the normal distribution. So this is exercise 9.3 in your textbook, and I'm going to work through a few with you to help you get an idea of how to do these. I guess it would be really helpful to you to first, before you view this video, look at the examples in the book and make sure you understand how those work. Key things about using the normal distribution to solve problems is you want to standardize your data using z equals x minus mu all over the standard deviation. That's your first step. Then you want to use phi z from your table, which is in your textbook. I think I've also given you a photocopy of it. And then you're looking at your probability, determine your probability, and I suggest, as your book does, to do a sketch. So what we're going to do now is we're going to try a couple of examples. The first one I have decided to do with you is 1a. So we've got some information in 1a. We've got x is normally distributed, and we've got our mean is 47 and our variance is 5 squared, so that means our standard deviation in this case is 5. And we need to know the probability that x is less than 56. Okay, well the first step here is to get our numbers into standard normal distribution. So we've got to know the chance that x is less than 56, so we're going to find a z number for x. So I'm going to say z is equal to 56 subtract our mean, which is 47 according to our information here, and then I'm going to divide it by the standard deviation, but this here is variance, so I'm going to put in 5 here. Now when I plug this into my calculator, what do I get? I get 9/5, or as a decimal, 1.8. At this point, I've got to, I actually probably would do the sketch first. So what am I trying to find? Here's my normal distribution. When it's standard normal distribution, I've converted this to standard normal distribution. We know that our mean is 0 when we convert it. I'm looking at a 1.8, so 1.8 is over here. And I need x to be less than 1.8 because we've converted 56 to the standard normal distribution. So I'm looking at all of this here. So in other words, I just need to find phi 1.8. So I could write probability that x is less than 56 equals phi 1.8. Now I go to my standard normal distribution table here, which you've got in your textbook, and all I need to do is find 1.8 as a z number. So I go down the column to 1.0, and then once I get to 1.0 I go all the way across to 1.8, and according to this it should be 0.8599. I'll just check that again. Sorry, that would be 1.08. I need to go down to 1.8 here, and so just to clarify, go down all the way z 1.8, and then we're going to go to column 0 because it's 1.80, so that should be 0.9641. So that is equal to 0.9641. Okay, so that is our first example. Now, we're going to do another example. We'll do part B. So I'm just going to rub this out and do part B now. In part B, this time we are trying to find the probability that x is greater than 51. So once again, we're going to start off with finding a z number, so we're going to convert this data into standard normal distribution. So z equals this here is our x, 51, minus the mean, which is this number here, and then divided by the standard deviation, which of course is 5. Now, we get a number for this, and I'm getting 0.8, or 4/5, or 0.8. Now, I can do my sketch. I'll probably switch these around, I think. So here's my sketch. It's my standard normal distribution. In the middle is 0.0. Now, I want 0.8, so that's going to be somewhere over here. This is 0.8. And I am wanting x to be greater than that, so I'm looking at this side of the line here. So my next step is, well, how do I get that? Because when I look up 0.8 on my normal distribution table data, 0.8 will give me this probability here from the left side of that line. So how do I find this side? Well, the whole probability is 1. So if I go 1 subtract phi 0.8, which represents that, I will get this side. So I would write it like this. Probability that x is greater than 51 is equal to 1 minus phi 0.8. And if I look up 0.8 on my table, so I'm going to go down to 0.8 and then across to the 0 column, and I get 0.7881. So it'll be 1 minus 0.7881, and that gives me a value of 0.2119. Okay, that's part B. Now we're going to have a look at part C to finish off. Here's part C. This time I am finding the probability that x is less than 42. Again, use this to find a z number. So z will be 42 minus 47 all over 5. Now this gives us a z number. According to me, I'm getting 1. Minus 1, sorry. Of course, minus 1. Okay, now let's do our sketch. Here on our standard normal is 0.0. We're looking at minus 1, so that's out this way somewhere. This is minus 1. We want the probability that x is less than this. So I'm looking at this here, this section here. How do I get that? Well, I know by symmetry that 1 greater than 1, this bit here, is equal to that bit there. So how do I find this bit here? Well, it's 1, the whole thing, subtract phi 1 will give me that. So since that is the same as that, I can say the probability that x is less than 42 is equal to 1 minus phi 1. And when I look up phi 1 on my table, I go to z 1.0, and I need the 0 column again because it's just 1.0. That is 1 minus 0.8413, which gives me a value of 0.1587. So that's the first question. I would encourage you just to check that you're able to get these these probability values from the table using the z value, just to make sure you're familiar with that. I'm going to upload this video. I will put some more videos on this exercise, but I just want to get you started because you might be wanting to do something this afternoon. Alright, good luck as per last time. Please email me if you're stuck. See you soon.